Good afternoon, everybody. Thank you for coming here for the 2 o'clock session. This is Laura Burns from Omega East. She does all the research and development, and I want to talk to you about the dialing in the haze.
Hi, everybody. Is it better for me to be closer? Yeah? Okay. I'm going to be about here. Today, we're talking on something that I think has been kind of figured out by a lot of you brewers already, but we've broken it down into a little bit more of the science to kind of get an approachable takeaway, like how do you get haze in a hazy IPA? And I think what most people have maybe come upon with luck is that it really is a yeast strain dependent thing. You can develop haze by getting the right yeast for your beer recipe. Okay, so if you're not familiar with Omega Yeast, we're based out of Chicago and St. Louis. Our production facility is in Chicago. We have a 30-barrel brew house. We actually brew like 14,000 barrels of beer a year for yeast. We're a production brewery, technically. We make everything for the customers that we have. We make everything to order. It's never something that we put in the fridge and store and wait for you guys to order. You put an order in, and 7 days later, that's the time it takes us to get that yeast going into propagation ready for you, and then we'll ship out a week later. You'll get it for your batch. We really value that model because it does matter how fresh your yeast is, and that first batch can be a make or break on a brand. So that's how we've kind of made our way into this industry, is just making sure that we get you the freshest yeast possible. Other mottos, obviously, I wasn't there at the startup. It was 8 years ago, and about maybe like a closet, basically, where Omega Yeast started, and I came on 3 years ago as the director of research and development. But even before I started, Omega brought on products like they were the first in the U.S. market with Lactobacillus plantarum strain, the first in the U.S. market with any bike yeast, and that was even before I started. But since I started, it's definitely been investing in R&D and pushing the envelope, making kind of like more information very accessible to brewers. So be creative, be helpful, be fresh. You can count on Omega for any of that. So today I'm talking about haze, and I'm just going to go through some like very basic background. Haze is it's less about color, it's less about kind of like necessarily perceived haziness. It's straight up the turbidity of your beer. It's like smoke or fog. It's how well you can see through that product and what particles are in the way and obscuring light. So typically color can be measured by absorbance, but haze is measured by transmittance. When you're thinking about hazy IPAs, the color of your beer might not be what's indicating haze, and a stout, I'll go through this a little bit, but stout may seem turbid. It's really not. It may be one of the lower turbidity beers you have, because it's really not related to the color of the beer and how light gets through that dark malt. It's really related to the particles in the beer itself. All right, so here's an example of like kind of our turbidity measurements, or our NTUs of different beverages listed here. So drinking water, or like a very clear lager, is going to be on the low end of NTUs. You're expecting, potable water under 1.5 NTUs. Lagers that you make in the brewery, if you can really get rid of some of that chill haze, you're going to get the brightest lager you can. So maybe your NTUs are even down at drinking water levels. Again, the porter, like where you might perceive that as a turbid beer because it's not really easy to see through it. It's actually not very turbid, and it can measure at the level of a lager or Schwarz beer. And then you get into other beverages like orange juice and milk, and those are known for very stable colloidal hazes, right? So milk proteins, pectins from the fruit, those are turbidity caused by colloidal haze. And so today we're really talking about that level of haze, colloidal haze that develops in your NEPAs, your hazy IPAs. So particles, definitely, like this is kind of an example of how haze is measured. Depending on the size of the particle, it will refract light at different angles. So sometimes when we're measuring haze, we're measuring in a 90-degree angle, and that's a nephelometer. And other times we're measuring, how much light passes through the substance, and that's more of a turbidity meter. So, not everything is going to measure the same unit, but if you have a measurement of turbidity in your brewery, it's definitely going to help you dial in consistency. When people talk about turbidity, if you have ever listened to a pitch from Anton Parr, they might even have a ratio of turbidity at a degree 25 versus a degree 90, and the degree 25 would represent more of a yeast-derived haze, and the degree 90 would be like your more colloidal haze. So when you're measuring turbidity in the lab and in the brewery, these are just kind of examples of different setups that you could have at a commercial brewery. We actually at Omega, we have the Anton Parr Haze QC. We do like it because it measures the 90-degree, 25, and 0-degree transmittance, so it has like a little bit more information there for us on larger or smaller particle size. This Optec haze control actually is very similar, but you can put a beer bottle right in it and measure out of package. I don't know if anyone is bottling still, but it's a really honest, it's a fun application of like being able to have a product go right into a lab equipment and measure it. And then in the brewery, there's inline meters, and most of the centrifuges that are in commercial breweries nowadays have that NTU measurement on the outlet. Some of them actually control NTU on the inlet and dial in the bowl speed and the pump speed to kind of target the NTU on the outlet, but most of them are probably measuring just that NTU on the outlet, and you can give, kind of like the dialed in centrifuge of a NEPA versus a lager based on the speed of that product going through the centrifuge. And don't be afraid to centrifuge a NEPA, and I'll show you why. It's very stable haze a lot of the time if you're doing it right. And we're all going for consistencies and yields on a commercial brewery, so it offers some of that reliability for you. So what kind of haze today am I talking about? Like, where is that haze coming from? It's dry hop dependent haze, so colloidal haze that's coming from the interactions likely between polyphenol and proteins. This is a lot of literature that has been done for the history of beer, a lot of lager literature, but we're fairly confident that it's a polyphenol protein derived haze. So think about polyphenols in malt and hops interacting with proteins like chordine or gliadin from the malt, stabilizing this kind of really colloidal milky haze. A very common misnomer is that, and I fell into this. I started brewing a wit beer first out in the brewery, and everybody said you had to store the keg upside down because you're gonna need the yeast to go back into suspension before it was serving. That is not the case, and we'll talk more about how to avoid kind of targeting yeast in suspension and non-flocculent yeast versus this colloidal haze that's more stable. So biological turbidity would be that non-flocculent yeast. We're talking about more of that non-biological turbidity, the physical interactions of the components of beer. So here's a model of kind of this concept of how these polyphenol and protein molecules are interacting. It's basically a bridging interaction between the prolines. Proline is an amino acid. It's part of protein in malt. And if a lot of the malt proteins are proline rich, and they tend to attract to the polyphenols, so they bridge an interaction, and there's a critical balance between the amount of polyphenol and protein, so that haze becomes stable. If you have too much polyphenol, you might have a crash out. If you have too much protein, I've actually brewed 50% wheat beer thinking, why the heck isn't this hazy? I dial it back to 30%, it was hazy. I got to the point where there was too much protein in the grist, and it was leading to that colloidal instability instead of having it stay in solution. So polyphenols come from both malt and hops. Paranthocyanins, the major ones, they're monomers, dimers, trimers, higher order polymers that help to build this colloidal network of haze. So different definitions of haze. You would talk about chill haze or permanent haze. If you're centrifuging a beer and you can put it into a water bath, a warm water bath, and the haze disappears, that is the chill haze that you would experience in a lager. But permanent haze is less temperature dependent. It tends to increase with aging. The idea is that it would originate from a chill haze but become permanent in the market. So even if the beer was warm, you'd still see it hazy over time. And there are different particle sizes here, as I've shown, where that permanent haze tends to be a larger particle size. All right, and briefly, because we don't talk about polysaccharides a lot when we're talking about haze, but there are polysaccharide origins to haze as well, and that's more of the malt-derived glucans and pectins from fruit, and also people have found that yeast-derived glycogen, amannins, and glucans can contribute to haze as well. So why do we want haze? Yes, that's basically what every craft beer drinker is looking for. Like, maybe not everyone, but the haziest beer on your menu might sell better. So why is that? So haze, from the Hofsteiner studies that were published over the last 5 years, it's basically acting as an emulsifier to keeping more nonpolar hop compounds in the product. So helping to kind of solubilize those hop compounds that are bringing more aroma to your beer. So that's the idea of, why these are so appealing, is it's actually helping to produce more hop flavor in your beer as well. Okay, so today I'm talking more about this second half. That was all intro. The second half of this talk is going to be much more oriented towards how yeast play into haze, and some of our more recent research kind of, mainly explaining some of those beers that you just didn't understand why it was hazy or not hazy, and you were maybe you were targeting hazy and it dropped clear. Well, we were really interested in why that was happening. Especially when it came to what the yeast was doing. So we'll talk about strain-specific haze, and then we'll talk a little bit about how dry hopping practices can help establish haze as well. So our experimental setup is actually 100% barley wort. There's no wheat, there's no oats, there's no adjunct. And we did that purposely to kind of make an isolated, kind of very clean experimental setup where we were really just looking at yeast, malt, hops, without a ton of variables at play. And also, if you're able to develop haze on barley, you should be able to develop it with adjuncts as well. So we did an experimental setup, and actually the origin of this project was not haze. It was actually dry hop creep. This is what we were trying to study initially, was like, how does hop timing, how can you maybe mitigate hop creep by changing up your addition timing? So you go from day 1 to day 7, where do we see the most dramatic hop creep, or maybe the most dramatic diacetyl spike? So when we were doing these experiments, we saw some much more interesting results on the development of haze through these different dry hop addition timings. But yeah, the experiment is like control with no dry hop. Our knockout dry hop is not a flame out addition. That's actually a knockout dry hop in the fermenter. So on day 0, before the yeast is pitched, add hops, cold side. I think I confused a lot of people with that one. But then day 1, day 2, day 3, day 4, day 7, and then we did a double dry hop where half of it went in early and half of it went in late. So these pictures, these little flasks, this is how our setup is, but this is the most obvious result we have from the start. We looked at 2 different strains, and very apparently the development of haze in those strains was dramatically different. So on the left-hand side here, is kind of the standard, I guess, hazy IPA strain, our version of 1318 L3 or juice or whatever you guys are using. It's called British 5 in our catalog. But dry hop timing, this is our control strain, our control with no dry hop. That's a knockout dry hop addition. And these are all after 14 days of fermentation, so there's no, this is done, this is terminal. But the knockout addition was surprisingly clear, and then our late additions at day 7 were adding considerable haze, and it was just increasing over time. And then if you looked at another strain, then typically this is our Chico strain, where you wouldn't necessarily be able to easily develop haze. We saw like nothing occurring, basically no pickup of haze over those dry hopping time points. And this is the actual NTU measurements that we got out of those experiments. Are you guys familiar with what would a standard NEPA on NTUs measure for you? Anyone? Around 700? This usually is a target. So out of barley alone, this day 7 dry hop at 2 pound per barrel with the Indiana grown triple pearl produced 700 NTUs. That's with our haze positive strain. But then looking at a Chico strain, we really saw absolutely nothing, which is, depending on what you're going for, that's also awesome. So terminal gravity, we wanted to just show the non-dry hop sample obviously had less of attenuation, but all of them basically finished up, or that's actually day 7, the non-dry hop isn't here. But hop creep was still kind of happening on that last sample, but overall, like the terminal gravity didn't really correlate to haze, so it wasn't something weird going on with this experiment. And then we kind of asked a similar question, and we were experimenting with a lot of our strains at this point. Which strains are hazy, which strains aren't? And we found our Voskavike was very hazy, haze positive. So we did an experiment where we just increased the temperature and said, like, okay, if I do an early dry hop at 70 on day 1, what is an early dry hop at 90 degrees? And we saw that, just by accelerating the fermentation rate, and moving up what would be considered early dry hopping, we were developing haze on that beer, even with a day 1 dry hop. So really that timing of fermentation, like time course of fermentation, later dry hops were helping to promote haze. All right, so this is just a handful of our strains that we have decent data on for whether they promote haze or do not promote haze. So this is the same experiment you were just seeing, with the day 7 dry hop and measuring the total NTUs after 14 days. And we just looked at a handful of our strains, and we found that, ones that are kind of closely related to 001, our 006 strain had a decent amount of haze. Our German Hefeweizen strain and Close strain also were pretty decent at developing haze with dry hop additions. And then our Voss and our London 3 were really the most haze promoting strains. And I feel like most of you in the brewery setting have experienced this, that those strains can definitely help to stabilize haze. So we also have a lot of people who like yeast blends to develop like either attenuation ranges or maybe flavor profiles that they like. They like Conan, but they aren't able to get haze. So before we knew that we had the data where we could define a haze positive or neutral strain, we were selling a lot of a Conan 011 blend to promote stable haze, but also get a nice peach apricot ester profile and a little bit more attenuation on the beer. And so we wanted to see on our experiment if we could also prove that the yeast blend was helping to promote haze. So our 052 blend, as you can see, definitely 50-50 of 011 and 052. We still get nice levels of haze. If you look at 052 alone, that's again like maybe your lager pale ale level of haze. And then our 205 or 200 our tropical IPA strain, when we blend that, similarly, it's usually haze, we call it haze neutral, but with the blend of our haze positive strain, you're able to maintain and develop stable haze on the product. So this isn't actually, so when I think about it as a yeast biologist, I'm thinking this is all like kind of genetics, like if I can blend a strain and I don't see that like haze is reduced, then I know that it's not like the haze neutral strain isn't actually doing things to actively remove haze, because it's not dominant. It doesn't remove haze from a blend. So we know now, like from this experiment, that it's a really interesting aspect of these hazy IPA strains, and probably another like kind of trait we can potentially even breed or select for. All right, so we've been working on a couple of like knockout pH. So how do you guys typically maybe manipulate haze? I've heard a lot of brewers would change their pH at knockout to kind of develop a stable haze, because pH ranges are pretty integral to maintaining that protein polyphenol interaction. And in our experiment, the first one we did was, okay, we'll knock out at a range of 4.5 to 6 and just see, you know, how different the haze is in the resulting beer. This one down here, we went really low, where we knew we would probably destabilize the haze into like a sour beer level. And we saw that haze was about half of the haze we'd expect. But when we knocked out between 4.5 and 6, our haze was relatively stable across those pH ranges. So the experiments knock out pH, dry hop day 7, see how hazy it is on day 14. We've done a couple more experiments. I don't have the results on the slides today. Those results we had with early dry hopping are probably more influenced by haze, or pH. So you can modulate. The early dry hopping aren't as haze promoting. We've shown that you don't get as much stable haze developing from those addition rates, but by manipulating pH, those may become easier to develop haze with. Okay, so this is my our research technician, Keith, and just to give you an idea, he is just nonstop doing experiments either on thiols or haze or whatever else we're working on, but it requires quite a bit of effort, and you know, that's one of the things we're nerds. You know, this is the kind of stuff we really like, but so you know, this is we are here, we're a resource, and we're trying to get you the best answers by using, you know, our expertise in the lab. Yeah, so from here, you know, we defined haze neutral, haze positive strains. We wanted to get a little bit more into like how hopping practices can influence haze. So, kind of not so surprising, but haze increases with the dry hopping rate. So you can see a half pound, pound, 2 pound, 4 pound per barrel. You just get increasing amounts of haze developing. So yes, you'll probably, if you're at 4 pounds per barrel, it's probably going to be a lot easier to get a hazy IPA. Not so surprising, we found differences between hop varietals. So certain hops produced a little bit more hazy beers. Like we started all of our experiments with this Indiana grown Turple Pearl, and just by chance, it's also one of the most hazy hops we see in our experiments. But you know, we talked a little bit about our haze neutral strains right here, and our haze positive strains, and the difference between a knockout dry hop and a day 7 dry hop to help develop haze. So on our haze positive strain, that day 7 dry hop really helps to promote haze, but just the variation between hop variety is pretty dramatic there too. So, you know, who says Galaxy makes the most hazy IPA they ever made? A lot of people. I've heard that. Like, people say that certain hops are better for hazy IPAs, but it may not just be flavor alone, but it's also the appearance of that beer. And then other products like Brew One from Haas actually helps develop more stable haze and a strain that you wouldn't anticipate haze from. So like Rogue, making their first hazy IPA, not using hazy IPA strain, used this Brew One and talks about how it helped develop stable haze in their beer. So, you know, there's manipulation of your raw materials that really promote haze, and it is a hop variety dependent thing. This is a little bit more data, but just showing, you know, we took different supplier, Cascade, Centennial, Citra, Mosaic. You know, we always kind of saw that lower level with Mosaic. And then like Citra seemed like to consistently be a little bit higher. Sabro was high consistently. We had Pato in here too. I know the YCH crew was just here, but some of those ones with packed and survivables, we tended to see a lot of haze develop in those as well. And because the most obvious thing was to look at polyphenols in hops, we wanted to see if we could use some different hop products that had different amounts of polyphenols, and if we could see the same impact, like more polyphenols equals more haze, and maybe that's the difference between varieties. And in those experiments, I don't think we had a good answer. A T90 pellet worked just as good as a polyphenol-rich pellet, or the result of like kind of like the leftover from a cryo pellet, more of the leaf fraction. So we don't have the answers on polyphenol yet, but we'd be really interested in knowing more to what that specific component is and helping to develop stable haze. The double dry hop experiments that we did early, we saw that if you did a knockout addition, it was haze neutral. If you did a day 7 addition, you would develop really stable haze. But what happens when you do a double dry hop with an early addition and a late addition? And from those experiments, you can see the flasks right here, a knockout addition and a double dry hop addition, where that axis is, oh yeah, those are different hops that we tested at the combination of them, sorry. Yeah, we consistently saw the effect of a knockout dry hop reducing haze in the finished beer. So just thinking about that, like did you try knockout hopping the first time and not get a hazy IPA? We've had a lot of customers with that exact scenario where I changed nothing. Everything within the recipe was very similar, but then really that subtlety of moving the dry hop up to like an extra 2 days, it made it not hazy. Then one other customer that we had actually, they were having issues with the true separation of the whirlpool, and they were getting hop transferred over to their fermenter. And once they basically built out their whirlpool to like get a packed cone and transfer less trube, they were able to get a much hazier, consistent IPA. So things to think about. We do have a little pilot system as well at Omega, so this was kind of like our, hey, let's brew a NEPA and see if we could see the same change in knockout addition with reducing haze. So this was with a haze positive and a haze neutral. Our haze positive strain 011. We whirlpool hopped to the pound per barrel Citra, YT Mandarina Bavaria, and then the hazy IPA was done with day 4 alone dry hop, and the experiment was to knock out with a half pound per barrel, but use the same amount of dry hops on day 4. And just a half pound per barrel dry hop at knockout here had the finished NTUs going from 487 down to 34 NTUs. And that's kind of the visual of what you'd expect to see in that experiment. But like I said, again, like the AE, pH, ABV, all of that it was very consistent otherwise. And on sensory even, like I think maybe we perceived like that clear beer or that non-hazy beer as being a little bit like West Coast vibe, but it really had like a very similar profile between the two. It was just the intensity kind of shifted. It's like a little bit harsher with the knockout addition. So what are our current kind of working ideas of what yeast is doing and playing into this? This is like a very old cartoon, but I don't have any updates. So yeah, we're kind of wondering like, is it yeast absorbing kind of particulate from the beer? Are they actively removing haze from the beer itself and resulting in clear beer at the end of fermentation? So that would be for a haze neutral strain. I think our experiments with blends have kind of ruled that out because we know that we can still maintain haze on a blend. Maybe there's a secreted protease that breaks down haze. We also don't think that one is probably true based on the blending experiments. But potentially these yeast, the Haze positive yeast, just have a different cell wall composition, and maybe, you know, some of their nanoproteins or cell walls proteins end up reacting with those polyphenols and proteins on a malt and help stabilize haze. And then maybe it's the impact of the yeast themselves on the conditions in the beer that promote haze development. So impacts on pH or impacts on non-covalent interactions. We're definitely, we've taken, you know, all these experiments have given us a lot of ideas. Our next approaches are to look further into getting really deep into molecular biology and biochemistry, so breeding approaches and proteomics. So wrapping up, yeah, so takeaways, I guess, like what's really, this is a lot of science, but like how does it come through in the brewery? We would definitely recommend a mid-late dry hop for helping to promote haze in combination with our select like haze positive strains. And you know, this isn't a product for us. We sell a lot of strains, a lot of other suppliers sell. Like you guys know those strains and their equivalents, but just thinking about, you know, how to develop a new recipe, not only for flavor, but from the yeast, but from haze itself. And then those early dry hop additions have, for our experiments, and it might not play out in every beer, you probably still get a hazy IPA with a knockout addition, but you're not helping the situation. You might end up losing what you wanted in haze by that early dry hop addition. And then, yeah, so I think not only for haze, but for biotransformation, helping with hop creep, speed it up a little bit. You know, cropping and harvesting your yeast for repitch. All of these play into why that mid to late fermentation dry hop is really ideal. Even with thiols, like, you know, you're not promoting the release of thiols with the early dry hop addition. We've done those experiments, it doesn't play out. We actually find that, you know, different additions in early and late, and you know, later dry hopping additions tend to preserve thiols, which we're working on that, but that biotransformation of a knockout dry hop is different from what we've seen in the science, and maybe we'll learn more about that. But for now, day 4 to day 7 dry hops are just fine for developing flavor and are very great for developing haze. Oh yeah, and this is just repitching from dry hop beers. This is like an extra slide I showed, a thing I did earlier this week, but it just, you know, mid to late dry hop allows you to kind of pick off the yeast in that cone right before dry hopping. Totally possible. Other reports, like if you look at the MBA technical, there was a good article from Jessica Young at Bearded Iris showing top cropping was a good method for hazy IPAs as well. But if you're doing day 4 to day 7 dry hop, especially with 1 and 3, like you're able to harvest yeast off of that fermentation before dry hop. So don't be too afraid, and it's going to turn out way better than if you wait to harvest after dry hop. All right, and that's our Omega team. I have my contact on here if anyone wants to reach out with questions, and definitely want to acknowledge Lance, he's the other PhD at Omega. We actually hired another PhD, so we're getting a little heavy. And then Keith and Chris are my research tech and innovation brewer that play into a lot of these experiments too. Questions?
So do you think based on what you're seeing that if we're trying to make the West Coast, would be better off
Yeah, I think like you saw in that one experiment where we had different hop varieties with the early and late hop addition, you know, we aren't seeing a massive drop in those haze neutral strains. So if you're using a Chico, you're still going to get pretty decent haze with the early or late dry hop. But when you're working with a haze positive strain, if you wanted to make a NEPA with a Voss, or a West Coast with a Voss or a London 3, yeah, you could, like just that last experiment we showed, like that small charge of knockout hops could help to make a bright beer. It acts as a fining agent, basically. Yes?
I'm interested in the strain dependency of haze formation, and wondering if you correlated it to, you brought up the baked yeast, and in my experience with that yeast, it's basically fully fermented in 2 or 3 days, whereas most yeasts, they're not fully fermented for more like 6 days. Obviously conditioning aside, would it be better to, getting my thoughts together, would it be better to talk about it as like percentage of fermentation completed?
Yeah, you're absolutely right, yes. And even the Kvike experiment where we ran it at 70 versus 90, like some people like Kvikes fermented a little lower. They think it's a little bit cleaner, a little bit more isolated aroma. So with those, you treat them like a traditional ale, like yeast on the timing of, because it's going to be similar like on its fermentation curve to a normal ale yeast if it's fermented at ale temps. But when you get up to 90 degrees, yeah, you might just use a 30% attenuation marker. Just as I'm going to dry hop after 30% attenuation, so I know I'm post-Croizon and I'm getting into, a part of fermentation where we're seeing more stable haze. Yeah, so that's where when you manipulate pH in fermentation, really you're manipulating the knockout pH because you're not really adding acids or bases into the fermenter. So we did that in our experiments where we just changed the knockout pH in a range of 4.5 to 6, and then terminal pH was kind of in that like 4 to 4.8 range for those beers. Yeah, and I think what our experiments are showing is maybe it's not so important or critical with a late fermentation dry hop, but if you're doing dry hopping early fermentation, yeast, obviously you're watching pH, so yeast is acidifying throughout fermentation. So that early pH range, where before yeast is really starting to drop pH, maybe that's where we're not seeing as stable a haze develop. So that knockout treatment with an early dry hop, like a knockout lower your pH to get a stable haze with an early dry hop, might be what you're seeing. Yeah.
What about water profile and its impact on haze?
Yeah, we haven't played a ton with water profile, but that does impact the buffering capacity and the pH of the beer as well. So if it's playing into pH, and that's something that we're kind of not looking directly at right now, but it could be. We haven't played with like chloride calcium sulfate kind of ratios yet, but.
Earlier you mentioned like Galaxy producing some Serranian beers. You guys experimented with like any groups of hops or noticing certain compounds that are more desirable to produce haze?
Yeah, so, we hopefully will have some more work on this. I think some of the hop suppliers have been interested in working with us, and when they have more comprehensive COAs, they can give us the information that we can run the fermentations. Like we partner, we get a little bit more of that information together. So we're definitely working on that, but we haven't, nothing like, from our end, like, we've shared our results, and from the hop supplier end, they're like, it's nothing like very striking that we could like, these varieties all share this commonality. There's nothing that really stuck out. All right, well, I'm up at the booth too, whenever you need to ask any more questions. Thanks, everybody.